started mowing lawns for his neighbors his freshman year of high school to earn some extra money. His annual earnings from 2010 to 2013 could be modeled by the function EVT, where T equals 0 represents the end of 2010, and EVT represents his total earnings for each year in hundreds of dollars. What were Joe's lowest earnings from between 2010 and 2013? And what were his highest earnings between 2010 and 2013? And when did these occur? You can use any method you want. I don't care. Whatever method you want to use to figure out these answers, you can use it. All right? There is no method that's better than any other. So in your groups, talk to each other, get your answers on your whiteboards. So first question, what were Joe's lowest earnings and what were his highest earnings? His lowest earnings for 1 year were, and I should have said for a year, but for 1 year were $100, which most of you guys put. So nobody just put a 1. You all, unless you didn't put earnings at all. But you guys, well done. So every single board in here had that, except for that one, you guys. Yeah, you just didn't put any dollar amounts, right? Okay. But the ladies. Okay. So anyway, but apart from them, you guys all had dollar amounts, so good. You had the lowest earnings, you had the highest earnings. You all answered that question. Second question, when did these occur? When I say when did these occur, don't tell me they occurred at t equals 1 and t equals 3. Tell me when, like if Joe asks you, when did I make the most money, you're not going to say at t equals 3, right? You're going to say in 2013. So make sure you answer the question in the context of the problem and how it's presented and how it's given. So if they say, when did these occur, and they tell you what years we're talking about and what T represents, then you should give back the answer in the context of the problem with years. But anyway, overall, well done. Most of you guys just listed the numbers and plugged them into the function, which was great. You guys just picked the right numbers. Did you have a method for just picking the right numbers?
We just tried it in our head.
You just did it in your head. Okay, so you did that mentally.
Yeah.
Okay, all right, that's fair. Same thing there. Same thing there. Same thing there. These two boards did something different. This board, these guys took the time to rewrite the equation in vertex form so that they knew that this was the minimum, the low value on the parabola, right? So the low value is at t equals 1. So I like that you guys figured out, like, remembered to use some of your algebra 2, right? Now, if you really knew your algebra 2, then you would know the vertex is just at negative b over 2a, and you could have just done it right here, right? But that's okay, because you showed me really good algebra skills. I like it. And I said any method was good, right? So that was their low point. And then I heard them say the high point has to either be at 0 or 3, which was really good because they knew it had to be at one of the endpoints, right? So I was very impressed by that. So well done. So yeah, that was really good. All right. This group did something that no one else has done today. What did they find? They found a derivative. And they said, let's find where the derivative is 0. Because we know when the derivative is 0, the slope is 0, which means we're going to be at a max or a min. In this case, a min, because it's an upward parabola, right? So they found the spot where the slope was 0, and that got them to the same t-value that you guys got over here, right? But then they kind of stopped there. But that was really good, and this is where we're going today, right? Is using derivatives to answer these questions. All right, good work. Let's get into the lesson. So, we are starting chapter 4. Chapter 4 is on applications of derivatives. You now are able to find just about every derivative in the world of any function that's handed to you. You should be able to differentiate it. What do we do with those derivatives, right? How do we use those derivatives? That's what we're going to be investigating in this chapter. So this chapter is applications of derivatives. The 3 main applications we're going to be using are going to be optimization, which is maxes and mins with word problems. So extremes, finding the biggest, the smallest, the heaviest, the lightest, whatever, the highest, the lowest, right? All the different extremes with word problems in context. So there will be word problems, right? So optimization, that's a big application of derivatives. Second application is called curve sketching or graph analysis. That's where you're going to be able to take a derivative and from the derivative sketch an accurate sketch of the original function. So I love doing that. It's one of my favorite things. That's going to take us several sections to cover. So that part of the that's probably the largest part of this unit is that part, is learning how to do that graph analysis, or what I call curve sketching. And then the third application, so let's see, we did curve sketching, we did, there will be more motion. We'll do more motion problems. So there will be probably at least one more motion problem on your test. So motion problems. In addition to those three applications, we will also have 2 new theorems to learn in this unit. So you all know IVT. In this unit, today we're going to learn EVT, and tomorrow we're going to learn MVT. And then you'll have all the theorems that you need pretty much for the AP exam. So anyway, so IVT, EVT, and MVT. And all 3 of those theorems are very likely to appear on your test. Okay, today we're doing section 4.1. 4.1 is squeeze theorem would never show up in the context of having to write a hypothesis and a conclusion statement and all that kind of stuff. It might show up in a multiple choice once in a while, but it's very rare. Squeeze theorem rarely shows up. All right, I can use derivatives to find max and min values. Today what we're doing is we're going to learn how to find absolute extrema on a closed interval. So we will later on learn how to find relative or local extrema, and then later on learn how to find absolute extrema on an open interval. But today we're just learning absolute maxes and mins on a closed interval. But before we learn how to do that, there's a few lead-in slides just so you understand what maxes and mins are. All right. So the first thing I do want you to put in your notes, even though this kind of looks like math jargon, and there's a typo on here, this should say less than or equal to. Because the College Board uses this from time to time, especially in multiple choice problems, it's kind of good to recognize it. So these 2 things, if C is some number in the domain of F, then F of C is the absolute max of F on its domain if F of C, the y value at C, is greater than or equal to F of X for all x's in the domain of the function. Meaning, if F of C, the y value at C, is greater than or higher or equal to all the other y values on the function, then that F of C is considered the absolute maximum value of the function. And then vice versa, if F of C is lower than all the other y values on the function, then F of C is considered the minimum of that function. So everyone knows, we all understand, max, min, but to put it in mathematical terminology, sometimes we don't know when we're reading it what we're reading. So it's kind of good to understand that a lot of times this is how you'll see it presented in multiple choice answers. Okay. Note, absolute extrema are y values. This is 100% no exceptions. College Board requires this. They are y values. You do not write absolute extrema as ordered pairs. However, WebAssign, I'm pretty sure, asks you to enter them as ordered pairs. So I'm just telling you, for WebAssign, you might have to put in these answers as ordered pairs, but for the College Board, If they ask you for the absolute max of a function and you put an ordered pair, you are not going to get credit for your answer. They will not accept it because they're saying then that you are showing you don't know the absolute max is a y value. So I had this conversation one-on-one with a reader to like triple check. Is this true? If they put an ordered pair, are they going to get credit? No, we got a straight up absolutely not. So you have to put them in as y values. So I apologize that WebAssign wants ordered pairs. The College Board does not. They want y values. So on your test, y values. That's what we're going to be looking for. All right. So for this little graph, I don't know if you can see this, but if you can see, so we have these kind of 4 interesting points with a bunch of other stuff going on in between. Those of you in the front can probably see better. Can you guys tell me what would be the absolute maximum value of this function?
5.
It would be 5. It's the highest y value on the function, and it would be 5. Where does this highest value occur?
3.
At x equals 3. This is the max value. This is where it occurs. Does that make sense? What's the absolute minimum value for this function? 2. Where does the absolute minimum occur? At x equals 6. So the absolute max is 5. It occurs at x equals 3. The absolute min is 2. It occurs at x equals 6. A couple little notes about terminology. The word absolute max and global max are interchangeable. So some books will call them global extrema. Some books will call them absolute extrema. It's the same thing. It's just 2 different words for the same thing. Anyway, when we talk about, when I say extrema, just know extrema with an A ending is plural. If you talk about a singular, like the absolute maximum, extremum is singular. So anyway, so extrema is plural, extremum is singular. Like you say absolute maximum if there was more than one, and maximum for a single max. Anyway, all right. One last little note about terminology before we move forward, which is if there is no adjective. So for example, if it just says find the max of f or something like that, you actually have every right to assume it means absolute max. So when there's no adjective in front of the word max or min, if they just say find the maximum value, they mean the absolute maximum value. So a lot of times the College Board doesn't use any adjective. They just say find the maximum value. By the maximum value, they mean the highest value on the function. They mean absolute. We'll get into relative or local in a minute. If they need relative or local, they have to say relative or local. But for absolute, they can just say the max or the min. So if there's no adjective, it's absolute. Right, Charles? Good. All right, everyone good? Okay. Before I know we have a lot of lead up. There's a lot of lead up slides. I apologize, but we got to kind of be comfortable knowing what a max or a min is. So this function has 5 interesting spots. These 5 spots are labeled A, B, C, D, and E along the x-axis. In your groups, just so you know, and I haven't even taught you what local extrema are yet, or relative extrema are. In your groups, I want you for each dot, the A, B, C, D, and E, I want you to decide if it's an absolute max or min, a relative max or min, both or neither. All right? So take a minute in your groups and just discuss for A, B, C, D, and E. Discuss if it's an absolute max min, a relative max min, both of those, or neither of those. Go. So for this first one, you know what? I'm going to skip that one because that one's the most controversial. We're going to go to this one. What do you guys think that one is? Is that an absolute max? No. Is it a relative max? Yes. So a relative or local max is like the top of a hill, right? And a relative or local min is like the bottom of a valley. Now, why is it called a relative? And we're not learning relative today, but I'm just going to give you a general idea of what they are. It's called a relative max because it is the maximum point relative to the points on either side. So if I am standing on a relative max point, if I look to my right, that point is below me, and if I look to my left, that point is below me. So I am the top relative to the points on either side. Local max means that it is the maximum value for a local region. So if I do a little local interval and say, hey, what is the absolute maximum on this little interval, it would be that point, right? That makes it a local maximum. Relative max and local max give you the same answer no matter what. So they are considered basically interchangeable terms. So relative max, local max basically mean the exact same thing. Even though it's kind of a slightly different mindset on how they're interpreted, the answers are the same. So if you're asked for relative max or local max, it means the same thing. All right. So what is that point right there? Local min. I will always use relative just because that's what I'm used to, but I have no problem with you writing local. So I'm fine either way. All right. What about this point up here?
Both.
That's both? Yeah. So it is. It's the highest point. It's the absolute max because it's the highest point on the whole function. And it's a relative max because it's the king of the hill. All right. And does everyone understand that? Okay. What about this little guy right there?
Relative.
That's just a rel min. All right. This point for... No matter what, this point is one thing. What is this point for sure?
Absolute.
That's the absolute min. The lowest point on the function. Is it a relative min? That's debatable. So you think there's no controversy in math? There's controversy in math. You go to any math conference, you're going to hear arguments going on, right? This is one of those things that people argue over. Is this point a relative min, or is it not a relative min? Now, Ryan's shaking his head no. So how many of you guys think this is a relative min? Yes, about a third. How many say it's not a relative min? About a third. Okay. All right. So anyway, okay, the answer is yes and no are both correct, depending on which side of the controversy you fall. Now, so because of that, I accept either way. I will tell you personally, I do not consider that to be a relative min. I was raised to not include the endpoints in my relative extrema, but you might have been raised to include the endpoints in your relative extrema, right? So whichever way you are raised is fine. I'm fine with that. I'm pretty sure, don't get mad if I'm wrong, I'm pretty sure that WebAssign does not include endpoints in their relative extrema. So I'm not 100%, I haven't done the relative extrema homework, but I'm pretty sure that that is a true statement. So anyway, I will double check that between now and when we actually have relative extrema, which will be on Wednesday. So anyway, because there's controversy, the College Board a long time ago published an article saying that we are not taking a stance on this. So because the College Board says we're not picking a side, they will never ever ask you about relative extrema at an endpoint ever. So every single relative max or min that they will ask you about will be on an interior of an interval, and they'll always ask it on an open interval so they don't even have to deal with the endpoints. So they don't want to get involved in math controversies. So anyway, yeah. So I will call it an absolute min. If you want to also label it relative, that's fine. Right? That's your call. All right. this function, which to me looks like cosine, right? We don't know for sure. It could be a shifted sign, but I would say this is a pretty nice graph of y equals cosine. I'm going to call that 1. I'm going to call that -1. This point right here, what is that point? It's an absolute max and a relative max. So is that one. You have absolute maxes at infinitely many spots on this graph. You also have absolute mins at infinitely many spots. That's not debatable. Now, but here's the thing. An absolute max, is that an ordered pair? Is that an x value or is that a y value?
Y value.
So y value. So if I say, what is the absolute maximum of this function, what would your answer be?
1.
1, right? The absolute maximum of this function is 1. There will only be one answer. It's the highest y value on the graph. It can occur at multiple places, but there's still only one highest y value, right? What's the absolute minimum value of this function? -1. Again, it can occur at multiple places, but there's only one absolute min. So absolute maxes and mins are y values. Relatives, you got to write as ordered pairs because they're all like different x's and y's every time. So relative, you're always going to, we'll get that on Wednesday. But anyway, just to make sure you understand what I'm saying. This is the line y equals 5. What is the absolute maximum of this function? 5. Where does it occur? Every single x value on the function. What's the absolute minimum value of this function? 5. Where does it occur? Every single x value on the function. Right? Do you understand what I'm saying? So there's only one max, one min, but it can occur at tons of spots. Right? Okay. All right. First theorem of the chapter. EVT, the extreme value theorem. If f is continuous on the closed interval from a to b, then f attains or has an absolute max value and an absolute min value on the closed interval from a to b. Of all the theorems we learned, this one I think is the easiest one to understand and interpret. Pranav, how are you? Yeah? Did you have a good weekend? Yeah. Good. Can you tell me the hypothesis for this theorem? You can ask your group for help if you need it.
If f is continuous on a closed interval.
Good, and I'm just going to write it like that. If f is continuous on the closed interval AB. Very good. Well done. Gavin, how you doing?
Good.
Good. Can you tell me the conclusion?
It has an absolute maximum on the interval AB.
It? Did you say it? What has an absolute maximum? F has an absolute max and min, right? Okay, good. So then F has an absolute max and min on AB. So in other words, every single function that's continuous on a closed interval has to have a max and a min on that interval. Every single one of them, no exceptions. If you are continuous on a closed interval, you have a max and a min. That's the EVT. So the only thing we have to check for EVT is that your function is continuous, which is also the first thing you have to check for IVT. And it's also going to be the first thing you're going to have to check for MVT. So for every single theorem that you have to justify, the first thing you're always going to be writing is if f is continuous. All right. Does everyone have these things written down? All right, 2 more slides before we can actually start in with problems. We will do problems today. There is homework. But first we got to learn a few more things. We got to learn what a critical number is. Critical numbers are also called critical points. They're also called critical values. Whenever you see critical number, critical point, critical value, it means basically the same thing. So a critical number is an x value in the domain of the function. Everyone always ignores that. It's really important. It's an x value in the domain of the function where f prime, where the derivative is either equal to something or is something. So I'll give you a minute to write. Critical numbers. Numbers in the domain of the function where the derivative equals 0. Right? It's not like it's going to be where the derivative is 2/3. Where the derivative is 0. Or the derivative is undefined. Critical numbers. X values in the domain where the derivative is 0 or undefined. Look at this top of the hill, this relative max. What's the derivative value there? 0, right? Slope is 0. What about here?
0.
What about here?
0.
0. So what about here? Undefined. When you have a sharp turn, your derivative is undefined. So slope is 0, slope is 0, slope is 0, slope is undefined. All 4 of those spots are critical numbers. All 4 of those spots were also relative extrema. Every relative max or min has to occur at a critical number. Now, absolutes, well, let's see. That was our absolute max, but that was our absolute min. This is another math controversy, whether or not this gets counted as a critical number. Again, I'm pretty sure your book does not include endpoints as critical numbers. I know I don't. We have other teachers in our math department who do include endpoints as critical numbers. We have chosen not to argue about it anymore. We have argued about it and we've decided to walk away from it. So some people think that endpoints are critical numbers and some people don't. I don't. Some people do. I'm going to let them have their own beliefs, right? Okay. So anyway, so absolutes, maxes and mins will either occur at a critical number or at what I would call an endpoint, right? Okay. So anyway, but relative are always at critical numbers. So, okay. So here we've got like some examples and stuff like that. I'm not going to get too deep into these. What I am going to ask you is an absolute max or min has to occur at either a what or a what. Let's see if you remember what I just said. Either a critical number or at an endpoint. So an absolute max or min has to occur at either a critical number or at an end point. Relative maxes and mins have to occur at a critical number. Once you have this written down in your groups, I want you to take 20 seconds. I just said that every relative max and min has to occur at a critical number. Does that mean, does every critical number have to be a relative max or min? In your groups, I want you to answer that with each other, yes or no. I give you 30 seconds. Go. No. So all relative maxes and mins have to occur at a critical number. Does every critical number have to be a relative max or min? No. And if not, see if you can figure out a counterexample.
Or undefined, so jump from like there's a distance number at 1.
Casper, did your group come up with an answer?
Sure. I mean, you should look at it. Sure.
You guys all went, oh, which made me think that there was some sort of conclusion.
No, that wasn't just me. It was Sean. You said when you said max or min, you have to imply that it's always absolute. And then
Oh, yeah, you're right. That is true. But I guess you're right. I should have said relative. I spoke the word relative, but sorry.
Sean, really.
Let's just talk about functions. It actually would. Yeah. So, all right, Anisha's going like this. Can you have this on a function? Absolutely. You can have a function, even though the function itself isn't vertical, the tangent line is, right? Which means if the tangent line is vertical, what's the slope of a vertical line? Undefined. So what's the derivative? Undefined, right? The slope is undefined, the derivative, pretend that this is drawn better, but the slope is undefined, the derivative is undefined, so this would be a critical point. Is it a max or a min? Nope. Anyone have any others? Yeah.
Wait, how does the tangent line ever like go straight vertical?
So I didn't draw it very well. Let me see if I can draw it better. There. So at this point,
They're always going to be angled though. You can't have multiple y values at the same time. So, like,
not on the function, but the tangent line, absolutely.
the tangent line would be following the function, right? Like,
Yes.
so it would be like against it.
So if we took the limit as our x value approached this value of the slopes, the limit of the slopes from this direction would be approaching infinity, and the limit of the slopes from this direction would be approaching infinity, and you'd end up with an undefined slope. So, yes, Pete.
What kind of function would cause that to happen?
I will give you an example of a function that will cause that to happen, but I can't think of one off the top of my head. But we do have some in our problems in this unit, so we'll see some sometime in the next 2 weeks.
Sine and
Okay.
cosine.
No, sine and cosine don't approach
Is
zero.
that when they cross the?
They don't go vertical. So, but what an easier one, you guys kept going like this. Guys, I'm surprised nobody just said y equals x cubed, which goes horizontal at 0.
Oh.
Yeah, there we go, right? So if you can have a function that goes horizontal, pretend that's more horizontal, right? That goes horizontal, but then just keeps on going, right? And it's not a max or a min. Or if you want another way to do an undefined slope, right? Just have a sharp turn. That's not a max or a min. Okay. All right. So not every critical number is a relative max or min. Every relative max or min is at a critical number, but not every critical number is a relative max or min. Yes, Luke?
What happens
When the slope approaches infinity?
or just like when the function's approaching infinity?
Well, when the function approaches infinity, you're talking about endpoints. Yeah. When the slope approaches infinity, that's when you get those vertical tangents.
So would then the absolute extreme and then just be infinity?
Oh, you're talking about for this guy?
Well, just
Like this guy, the absolute extreme, it depends on what he does over here. Like if I drew him well, like say he kind of curves and I don't know what he's going to do. This would definitely be a relative max. That would definitely be a relative min, but who knows what those endpoints are doing.
Well, like,
They go on forever. There's no absolutes.
something approached infinity would the absolute extreme of that be infinity?
There'd be no absolute max.
Okay.
Yeah. Which is why all we're doing today is absolute extreme on a closed interval. Because if you just have this, right, this function right here, there is no absolute max or min. Because it just goes on to infinity. Okay. So, all right. But today we're just doing closed intervals. We'll do open intervals another day. All right, almost done. Steps. Wow, we've spent a lot of time discussing. That's okay. So we're going to walk through problems. I'm probably going to skip mathematician. Well, yeah. I don't know. All right, we'll see. Okay. So to find the absolute max and min, step 1, please follow these steps. Don't do your own thing. This is one of those times where I'm just going to ask you, please be a sheep. So step 1, find the critical numbers. Step 2, plug the critical numbers and the endpoints into your function. Step 3, the biggest number is your max, the smallest number is your min. That's all there is to it. Find the critical numbers, plug the critical numbers and the endpoints into your original function, write your answer. The biggest is your max, the smallest is your min. Because every max and min has to occur, every absolute max and min has to occur at a critical number or an endpoint. So you just have to find your critical numbers and test your critical numbers and your endpoints. Yes, guys?
Could you repeat them one more time in layman's terms?
I can.
Thanks.
Okay, so step 1, find your critical numbers. Step 2, test your critical numbers and your endpoints by plugging them into your original function, not your derivative. If you plug your critical numbers into your derivative, every single one of them is going to give you 0 or undefined, because that's how you found them, right? We're not testing derivative values. We're testing to see what has the biggest y value and the smallest y value. So you plug into your original function, and then step 3, biggest number is your max, smallest number is your min. This is all you need to justify your answers. There's going to be a lot of writing in this unit, but not for this section. This section, you don't have to write because statements. You just have to show that you've done these steps, and that's all you need. Okay. All right, we're going to do an example. We're going to walk through this a little bit together. Find all the critical numbers for f of x equals x minus 1 to the 2/3. This is one of my favorite functions. I call it the bird function. I'll show you why in a little bit. Then locate the absolute max or min on the interval from -1 to 2. So what I want you all to do is take 30 seconds and find the derivative. Tyler, what'd you get for your derivative?
3x minus 1 times,
Just walk me through, yeah.
2 over 3 times x minus 1 to the -1/3.
Good. times 1, because chain rule, but it's just 1. All right. In this unit, you're going to be thankful that we made you simplify all your functions in the last unit, because you have to do it in this unit in order to figure out how to get these problems right. So I'm going to write this back in radical form, no negative exponents, nice, clean, happy, rational function. When you're finding your critical values, the derivative is 0 where the top is 0. The derivative is undefined when the bottom is 0. So when you're finding your critical values separately, you set the top equal to 0 and solve. You set the bottom equal to 0 and solve. Is the top ever going to equal 0? No, it's a constant of 2, right? So that would be silly. So the only critical value is if you set the bottom equal to 0. What does x equal? 1. You should be able to look at this and know that x equals 1 to make that 0, right? If not, I mean, if you have to divide by 3 and cube both sides and add a 1, then do that. But I'm hoping you'll get to a point where you'll be able to look at this and say, oh, x is 1. So our critical number, is that in the domain of the function? Yes. The domain of this function, by the way, is all real numbers. It's a cube root, right? Okay. All right, so our critical number is at x equals 1. So now what we're going to do, here's what I like to do, and the College Board loves it if you do this. It makes it really easy for the readers to find what your justification. So if you actually write the word test, they like that. Like this is like a, oh, this student is making my life easier kind of a thing. You want your reader to be happy, right? Okay. So just, reader means the grader. Like they call them readers. So anyway, so we're going to plug in our critical number and our endpoints, right, Anthony? What are the endpoints? -1 and 2. Are we plugging them into the derivative? No. Where? Original function. If I plug in a 1, what do I get? 0. If I plug in a -1, I get -2 to the 2/3. 2/3 means like 2 is your power, 3 is your root. -2 squared is 4, so this is the cube root of 4. F of 2 is 1 to the 2/3. What's 1 to the 2/3? 1. So you find your critical numbers, you test your critical numbers and your endpoints by plugging them into the original function, and then you write your answer. So our absolute max is what? What's the biggest number of these three?
Or 1.
Are you sure it's a cube root of 4?
Yes.
Why?
To make something bigger, it has to be bigger than 1.
Very good. And 1 is the cube root of 1, right? Okay, so the cube root of 4 is going to be bigger. All right, what's the absolute min? There shouldn't be any controversy here. 0. Done. Y values. That's it. Does everyone understand the process? Yeah, Tarun.
I don't get why we set it equal to 0 for the denominator.
Okay, so every max or min has to occur at either a critical number where the derivative is 0 or undefined, because undefined could be a sharp turn, right? At either a critical number or an endpoint. Every max or min. So we find our critical numbers, and then we test by plugging in, just find the y values at the critical numbers and the endpoints. Since every max has to occur at one of those, whatever the biggest number is has to be your max, right? Whatever the smallest number is has to be your min. So critical numbers are where the derivative is what or what? 0 or undefined. Critical numbers are where the derivative is 0 or undefined. All right. I love Catherine Okikiolu. She's awesome. I want to talk about her, but we only have 4 minutes left, and I do want to do our last example. So I'm going to skip her today. Catherine, I will come back to you tomorrow. All right. So we're going to do this one because this one has some really good algebra in it.
Yay.
Okay, what rule are we going to have to use for the derivative? Product and chain, right? All right, I give you 20 seconds to write the derivative of the first line of the derivative of this function. All right. Alec, you ready to walk me through this?
Sure. So you have to do product rule.
Okay.
So that would be 4/3 times, and then you do or 4/3. Yeah, 4/3, and then in parentheses you get the square root of 3 minus x.
Good.
And then you add, and then you just have the 4/3 x. And then you do, like.
You can just tell me without simplifying.
It'd be like -1, or okay, 1/2 times 3 minus x to -1/2 the power times -1.
Times -1. Why do you multiply by -1? Chain rule. So important. If you don't have that -1, all your answers are going to be wrong. And these problems, I'm telling you, we're on day 1. This is going to be like a 12-part problem by the time we're done with this unit. You can't mess up your derivatives. All right? Okay, so here's how we simplify before the bell rings. You have to get your answer to one fraction. So I'm going to clean this up a little bit. So first I'm going to go ahead and cancel this 4 and this 2 and make that a 2. So on top, what's on top of this whole thing? 2x. On the bottom, 3 root 3 minus x. What am I going to have to multiply this term top and bottom by in order to combine these? Root 3 minus x. So I end up with 4 times 3 minus x minus 2x all over my LCD. Getting comfortable with LCDs is really important. It's the only way to find your critical numbers. It's to get it all in one. That's one nice big rational function. So I clean this up. I get 12 minus 6x over 3 root 3 minus x. And I'm going to divide out a 3. So you get 4 minus 2x over root 3 minus x. Bell's going to ring. I'm going to see if I can finish this real quick. Set your top equal to 0. What's x? 2. Set your bottom equal to 0. What's x? 3. So I get critical numbers of 2 and 3. Are those both in the domain of the original function?
Yes.
Yes, then those are critical numbers, even though technically one of them is an endpoint. So critical numbers would be x equals 2 and 3. We test by plugging in our critical numbers and, oh, I didn't look at the interval, and the endpoints. So we're going 0 to 3, so the other endpoint would be 0. All right, I'm going to rewrite my function. So my function was 4/3 x root 3 minus x. So f of 2 would be 8/3 F of
The
3
following
is 0.
students,
F of
please
0
come to
is
Student
0.
Center East Counseling
So our
Office.
max
Adriana Blanco, Miguel Flores, Ava
is 8
Grell, Victor
thirds,
Grin,
and our min
Jacqueline Grunstein,
is
Tim
0.
J, Olivia Kramer, Student Center
we are
East
done.
Counseling Office.
All right, guys, have a great day, and I will see you tomorrow.
Counseling, Carl Miller,